You know what's in there, Jason? It's just air. I have some air in that container right there. Do you know what happens when you get air really cold? What happens to it? It turns into a liquid.
Liquid nitrogen.
Did you know that air can turn into a liquid? Let's have Miss Adrienne Powell pour us some air into that container right there, and we'll see what it looks like when it's really cold. Go ahead. Just grab it. Yeah, grab it. Let's see what happens when. So all it is, it's just air in there. Nitrogen. It's in the air. There's just air in there. Let me help you. Grab it here, and then pour from the bottom. There you go.
Do we want to touch cold air?
Well, it's not white.
Water. That's water? I mean,
It's not water.
It's liquid nitrogen.
It's air. It's just really cold.
So what's missing?
And I like to spill it all over when I do it, kind of like this. And it makes clouds. It's just air. See, there's no water in there. It's just air. Did you step on it? Cold? Don't tell the camera.
It's like.
All right. Alyssa, I want you to grab this balloon right here like this. Watch what happens to the balloon when it gets really cold. Okay, you think you can do it? Okay, just slow. Put it in there. What's happening? Anything happening? Push it in there. Push it in there. Oh look, where's the air going? Where'd all the air go?
Oh my gosh, you're sucking the air out.
Where'd the air go? I'll blow back up. Who else wants to try that? All right. I've got a whole bunch of balloons. You have to be careful not to put your hand in there, because what happens if you touch your hands? Gets really cold. You can stick your hand in there really fast.
Don't encourage them.
So what's happening? Who can tell me what's happening? Jackson. It freezes it, or it makes it a liquid. Yeah. And what happens when the air turns into a liquid? It condenses.
It's smaller.
It gets smaller. Okay, there you go, Haven.
And I thought it was magic.
All right.
Next.
What's next on the agenda? Let's do this. I'm sorry, that's all the cold I have, so we're going to have to get hot now. So the first thing we're going to do, I have a whole bunch of balloons here. Okay?
More balloons.
I'm going to have my assistant, come out here in front and grab the Harry Potter one. And we're going to see these balloons have different forms of energy in them. Okay? I want you to tell me which ones have the most energy, okay? So we're going to start with that one. We'll light your Harry Potter wand here. Ready?
Put your hair behind you.
Don't blow up.
Okay? Let's see what's in the first one.
Wow.
Ready? Go ahead.
I'm going to guess.
What was in that one?
Air.
It was just air. It didn't have oxygen's a fuel, right? But it doesn't burn by itself. That one was full of hot air from Ivan. Okay, this one.
Has a clip. That means it'll be.
Looks like this. H.
Oh my goodness.
Here, the very first one way up there is H.
Yeah, that's
The very first one.
Everybody stand back.
Let's do it.
Wait till Haven
Whoa, Naomi, look.
Come over here. Stand back a little bit. We're going to do this.
I can't
It's going to make a bigger explosion. It's heavy hydrogen.
No, it's just regular.
Oh my God.
It's
It'll blow you.
It's not heavy.
That's it, huh?
Oh, it went out.
Oh, it's there. There it goes.
You're pinching it right there. Okay. This one has HH in it. And we're going to break that HH bond, and we're going to see what happens. Ready? Whoa! That was pretty good, wasn't it?
Let's go to
Well, this one has
Lisa
dancing in
and
it.
Christy.
We'll do this one next.
you're
Okay, don't pinch it. Okay, here we go.
Back one.
Whoa!
I would go
That one was butane. I think that's what you use in your barbecue at home, right?
Yeah.
But it's got a lot more energy in it. That looks
That
like
was
this.
really hot.
There's lots of H's in that one, so that one had a lot, even though it was a small balloon, had a lot of iron. Now this one
Is it okay that the plastic
Ashley, you
was
might want to come
engulfed
back.
this one's huh? Is it on the floor burning?
No, is it okay that the plastic tub right there was engulfed?
Yeah.
Okay.
Oh yeah, he's a man.
They won't catch on fire. All right.
Maybe the movies.
That's off. This one looks like this. Okay, so not quite so many.
You should have just erased some of the others.
Yeah, but there's more of it, so let's see what happens.
Methane. Methane. There we go.
That's pretty good, huh? That's the same thing we use in our furnaces at home. When we burn fuel, it heats our house and makes it warm. Okay.
Are
What
you
else
sure
do
this
we
lab
have?
is fireproof?
This, though, this right here, oh, we'll have to wait. No, we'll have to wait. That one's got to get going. So, where'd my torch go? Torch? You can give me that now. Thank you very much. Time for my lovely.
Okay, now he's going to keep.
All right.
Oh, we better watch now.
No, this one's just...
Jackson knows what this one is.
Yeah.
Right, Jackson?
Yep.
Jackson,
Oh, I know what this
It's going to melt something.
Throwing
See the white
gummy
stuff, Jason?
so,
Look at that.
this is my favorite kind of energy right here. Anybody know what that is?
What is that? Is it?
Huh?
Gummy bear?
That's a Swedish fish.
A Swedish
Gummy bear.
This is the growling
Yummy.
Swedish fish experiment.
Yummy, look this way.
We gotta melt it first so it gets hot. So we're gonna see how much energy is in this little Swedish fish right here. So you moms can't tell your kids anymore that there's not energy in those gummy bears.
Yeah, we don't want that. There's a lot of sugar.
Alright, ready? It's the wrong kind of energy because it burns so fast, right? Yeah, now we're going to see how fast it burns. Alright, getting close, getting close.
Is that the Swedish fish?
This is the Swedish fish.
Oh, sorry.
That is molten sodium potassium perchlorate.
Oh, that's right, I forgot.
Yeah, so don't mix the two up because if you eat one and not the other, you're in danger.
Hold to daddy, hold to daddy.
Okay, you ready? Almost there. Wait for it.
Drop it into the tube.
Calories transport?
Yeah. Is the air still sugary?
You would like to...
I think we want to do the fire tornado next, right?
Yeah. I love the fire tornado.
Okay, so what we're going to do, in here we have a little bit of copper. Come here. You ready? And a little bit of fuel. This is ethanol, the party fuel. Just pour all that in there. Yeah, just pour it in there.
Here.
Okay, now I'm going to just have you strike a match and throw it in there.
Get closer, Levi. Come on.
Just light it and then throw it in there. Oh, this one's better with the lights off.
Don't miss. Don't miss.
Go ahead, throw it in there. Yeah, is it on? Okay, one more time. Go ahead. Do one more. One more match.
Yeah, it's not going to explode or anything.
You can, it's not going to flame.
Okay, Uncle Bill. Whoa.
All right? All right. So I have a little bit of fuel burning in there, and when I turn it, it's going to make more oxygen. Come over here. Go ahead, you can turn it. Slow. Slow. Start off slow, and you'll get to an optimal speed. It's a little bit green because there's a copper in there, and we'll do something else to go faster. Just slowly build up speed. Faster, faster. There we go. If you go too fast, it'll come off the wheel. Faster, faster. Do I sound like Willy Wonka? Faster. Keep going. Come on. You're getting close. Ooh, there you go. Faster.
That is cool.
Faster. Faster.
That's gotta be magic.
Just keep going. Just faster, 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 faster. Whoa! Woo! Is that a tornado?
It's a tornado
That's a
fire.
pretty cool tornado, huh?
Let's see if we
Look
can.
out, it's coming out the top.
Come on, Adrian, go to the ceiling.
Faster. Let's see if we can get it to the ceiling.
Faster.
Eventually, it won't go any faster. That's pretty good, huh? You can't
That
see
is
it?
awesome.
Woo! Woo! If you look, there's a little bit of purple and green in there.
Good job.
Tornado! I wonder how soon it will go out. Eventually it will go out. But I need some gloves because it's warm. I'll be right back. Nobody touch it.
Nobody touch it.
It's warm.
Oh, you're a pretty good musician, Adrian.
What?
You're a pretty good musician. A good magician.
How did the lights turn on by itself, Ashton?
I turned them on. And then, ooh, you see the purple and green?
Yeah. Wow. What did he do?
Alright,
Keeps the air away so there's no fire.
now, up here I'm going to show you how they make the different colors in fireworks.
Oh boy.
You ready? Okay, but only the older kids can come up here and scratch it up a little bit. So I'm going to put some ethanol in there. Scoot back a little bit so everybody can see. Well, in here I have just different salts, and I'm just putting some ethanol in there to catch it on fire and burn those salts just a little bit. It's probably lots.
And what different kinds of salts are you?
I have potassium chloride, I think I have sodium chloride and zinc, I've got some copper, and I've got some, I don't remember what this one is, lithium fluoride. Fluoride's good for you.
Well, it's also poisonous.
Okay, I'm going to light these, and it works best if you mix it up a little bit, so I'll have you do it one at a time, and we'll see if we can see what color the flame is. Alright. Try that one? No? How about this one? Yeah. Alright, I'm going to light them up. Here we go. Let's start over here, and we'll have Jackson come mix it up, if I can get it to put on fire. Alright, mix it up. Show us. Anybody see any colors in there? What colors do you see? Green. So if you have a green firework, they probably put copper in there. They probably put copper in there. Spilled some to make it green. Okay, let's go with the next one. You can keep mixing if you want. Who Ashton? Ready? Okay, mix that one up. See if we can get any color. Oh, yeah. Come up to the side a little bit so people can see. And mix it up. Who sees any color in there? Wow, look at how pretty that is. Woo! All right, who else has a stick? Miss A. Here's your stick.
Red.
That one's lithium fluoride. Okay, look at it. Come on the side. See if we can see what color that one is. I think it's just blue.
It's blue, yeah.
Yeah, that's pretty blue, huh? And I've got one on the end here, so you'll have to stick up a little bit. Problem is the lids are underneath. Okay, here I go. What's the last one going to be? I think there's a little bit of red in there. I think this one has too much metal on it. Maybe yellow? Okay, everybody come over here, look out, and stand behind the counter. Alright, I'm going to put them out. Yeah, is that pretty cool?
Yeah.
Sweet. And the lid, once you put the lid on, just put your thing down. Alright. While we're here on colorful fires, let's do this one right here. So this one, what we're going to do, we have a little bit of rust here, and we're going to turn that rust into molten iron. Okay? This is called a thermite reaction. I'm going to ask A to come over here. So I have some Fe2O3, iron oxide, rust, and I have some aluminum powder. And aluminum powder is going to help, it's going to take the oxygen basically from your iron and turn it into liquid iron. Ready? Just what I want you to do is pour the aluminum. It's not going to catch on fire until you put it in. Pour the aluminum in there, stir it all up, and then pour it right in the top here. Looks like a chocolate brownie cake. Yeah.
Making chocolate mousse.
Yeah.
Can I do the
Stir it all up so it's good and homogeneous. Alright, got it all mixed up good. Pour it in there. And what we have here is a magnesium fuse. It's just magnesium metal. If we only have to use one, maybe I'll give the second one to Levi. Alright, we got it in there? Ooh, let me see. Real fast. Wonder if we got enough of the aluminum into that. It's been sitting around for a little bit.
Hey, see, it's a pottery class.
Alright, here we go. Let's give it a go. Let's see if we can't get it to ignite. Okay. Torch.
Levi, you might want to step back.
Yeah, you're going to want to get back by the chairs. Make sure this is out of the way. Maybe we'll reignite one of them.
Naomi, look! Naomi, look!
Gonna catch it on fire.
Hurry!
Everybody watch.
You're gonna miss it.
Okay, so grab this. It's going to light the fuse first before we have some time. Just come in here, right here, and light that fuse. Just put it on the magnesium until it gets on fire. Just
Naomi, look! You're missing it.
take some minutes.
Okay.
Okay, there it goes.
Oh! Oh!
Oh, good. Look, we did reignite some of our flames. So this is molten iron.
Molten
Now,
iron.
does Adrian need to turn out her,
Woo!
Like on the sun?
That's amazing. I'm going to do that next time, like relight all my other ones. See how much heat that's given off? That's amazing. I've never seen it in the dark like that before. Usually we put a pumpkin on it, and then it glows in the pumpkin. That's a jack-o'-lantern. Woo! So that reaction got hot enough to melt the iron. And they used to use this to fuse, and they still do, railroad tracks together. So put some in, it'll light a fuse, it'll go in, and it'll melt the iron, and it'll melt the iron around it too, so it fuses it together. Woo! It's like lava in there. Check it out.
What did you use?
See that crust? And then like in the inside it's hotter. Whoa! You can like feel the heat off it, huh? Isn't that crazy?
away to see it.
Woo!
Whoa.
Alright, let's put these out, huh?
See it? How it's all glowing? It's like metal.
See how hot? That's metal and it's so hot it's glowing. It's like a flashlight.
It's like a lava rock.
It's like a lava rock. You want to take it home with you? We'll have to put it in the water before.
All the way back here?
Feel how warm it is? Crazy, huh? It's like the stove. It's so hot it glows red.
Got some liquid nitrogen?
I do, but that's dangerous. Never put something really cold on something really hot.
Yeah.
Alright, lights, camera.
He's like, whatever.
See, now you see, in the light it looks just gray, but it's still glowing red inside. They give me a lot of that. I caught the carpet on fire a little bit back here, but... Shh. Alright, what else do we have? We have...
Blow up more.
Let's blow up something else, he says. Okay, for this I need
a
Elephant
volunteer.
Where's Callie? Callie, you want to come do the elephant's toothpaste?
No, can I do it? Can I do it? Daddy! Daddy!
So I have some potassium iodide here, and I'm just going to mix it with this hydrogen peroxide solution, and there's soap in it. Okay, so the soap is going to catch the air that's released. It's going to catch the gas. Now we're going to let Callie do it, because she can be able to...
What percentage is it?
This is pure potassium iodide, and I think it's like the 30% hydrogen peroxide you buy at the store. Okay, what I want you to do, stand off to the side a little bit so everybody can see. I want you to pour it in quick, go like this. Or just pour it in and then step back so everybody can see. Ready? Go. It's elephant's toothpaste.
He doesn't know when to quit.
Woo! It's like, okay, you can step back now.
Yeah, can you do it again and I do it?
That's the only one I had, sorry. Okay, let's come over here next, and let's get Alyssa to come over here. And she'll do this one. I'll let you do one in just a minute, okay? Maybe. Okay, Alyssa, come right up here in front. Right here I've got a solution. It looks just like water, but it's got something in it.
You see that yellow one?
I want you to grab that and this little scooper. Okay? It has a whole ton of a chemical dissolved in it. It's sodium acetate. And there's so much in there that all we have to do is add just a touch of something else and it'll all crash out. So just, quick! Oh, it already went. We didn't even have to add anything. I opened it and some dust got in. And it all crashed out. That's all you need is just, it's a little warm too. It all turned to a solid.
Again. Can you...
No, I can't do it again, sorry. That was enough. Just a little bit of dust was enough to start it all coming out. Thanks though. Alright, this one's one of my favorites, but I need somebody tall. Hey, I need you over here. She's going to climb up on the counter.
Ooh, that's a fun one.
Climb up on the counter. Don't try this at home. Or in the chemistry lab. Okay, what I want you to do is you're just going to go like this. A little tricky. I'm going to pour at the same time. It's not for trying about the same time and about the same rate. I'm going to hit the lights. Ready? Tell me if you can't see enough to do it. Alright, here we go.
Can you see what you're doing?
Oh. Okay, that's enough. We don't want to overflow the beaker. That chemical reaction makes light. It's not hot. That's like what happens in your glow stick.
Oh, really?
When you mix two chemicals together, it glows a different color because it releases light. But the ones they do in your glow stick are probably a lot more concentrated. Beautiful. Thank you.
That was cool.
See it glowing? I have this reaction, and it's going to make pretty colors. Okay? So I need everybody to pour just a little bit of one of these in there, and I'll help you do it, okay? It doesn't happen until we get them all through mixed. First we need the A. Okay, Jason, I'm going to let you do the A, okay? So here, Mom will hold this. Grab on here.
Anna should.
Okay, I want you to pour just right. Here we go. Look, he's a chemist, everybody. He's going to do a reaction. All right there. Good. Thank you, Jason. Hold on to that, Heidi. Yeah. All right. Thanks, Jason. You can go sit down. Alyssa. B. Grab this one. Here we go. We're going to pour. Haven. Sorry. Haven. Here we go. Pour it in there. Yeah.
You okay, bud?
Okay, bud?
Good. Good. Now, thank you, Haven. Go sit down so you can see it. Here comes C for Anna. Let's put this in the cake. Go sit in your seat so you can watch. This one's for Anna, and as she pours it in, I'd like Heidi to stir it up. All right, thanks. Ooh, look, it's changing colors. Whoa!
Whoa, it went black.
Okay, now let's just put it right here.
Blue.
Watch this. It's got magic. To make it start over. Oh, here it comes again. Whoop! Oh.
Drink it.
No, we don't want to drink.
There we go. See, I'm mad. I'm gonna start it over. Ready? Oh, here it goes.
Keep blowing it, cheese.
So how many times can you do this? Can you
I think it goes a whole bunch of times. As long as I want to blow on it. There it goes. Oh. It's just an oscillating reaction.
Can I blow on it?
As it builds up, they like decompose to other things. There we go.
Never known you that.
Oh. Do it again. There we go.
Yeah, now everybody wants to
Here,
blow.
let's let Jackson blow it this time. Ready to go. Okay, go blow on.
Let's do me.
You just blow on the side of the glass, Jackson.
There you go. You don't really have to blow on it. I just don't know because I'm
Actually,
it just does it by itself. Yeah.
We just sit here and watch it.
That's just part of the magic, right? Yeah, let's just keep going. Okay, Alyssa, ready after it goes again? I'm black. Okay, go up. Now, give it a good blow. Like harder. Harder. Blow it. Blow it. There you go. Good job. That's all the experiments I have. Unless you want to play the magic tomorrow with the balloons. Sure, you can keep it. Let's do it off the right this crack.
Look, Naomi. I got you. It's cold.
Yeah, it just freezes the balloon solid.
Oh, it's condensing the air inside the balloon right now, right? But it works faster if you have more surface area. So that's why those balloons are good, because it condenses the air faster. But now it's just slowly condensing. It's probably going to pop on the way back
You have
up.
like dust or something on your hair. When you're down, I can
Yeah, check that out.
put it in my
I didn't do it again. That's about as small as I'm going to go, because around here, if I touch it, it's frozen. Now, if you look in the bottom, see that? See all that liquid air in there?
Yeah, you kind of see a little bit in there's one.
He's like, oh, he's...
Look at all that liquid air in there. That's awesome. It's freezing the balloon. It's going to pop with it. It's freezing the balloon, and so it can't expand, right? So
Look at this. It's solid.
a little bit of, see that? See that in there? That's the water that was in
Look
there.
at that.
It's still frozen.
I
Yeah.
froze the balloon.
You're going to make my water cold?
Yeah! A little balloon.
Is that
Watch it. When I pour it into the top part, which is warmer, it quickly expands. And then the frozen part that's not expanding.
Oh.